Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So it's been amazing for all of us involved in the Kinect for Windows project, because it's just such an incredible diversity. And you've seen there some of the business scenarios. What I'm going to talk about now is some of the science scenarios that we see that this technology can be used in, and what in particular people like yourselves are telling us that it can be used for. And I hope that you come away from all of our talks today inspired to try out what you would like to try with Kinect. Kinect is really not so much about what we in Microsoft are saying, is what you can bring with your applications and your ideas to this amazing technology. Just heard from Cherry. Again, I'm Stuart Tansley. I'm from Microsoft Research Connections. Let me talk a little bit of context before I get into the science of this, to tell you who I am and where I'm from and why you might listen to me. So I'm from Microsoft Research. Microsoft Research's mission is very broad. We are a pure research organization in a company, which is extremely rare. We do what some people call big R research, where the emphasis is on research. It's about publishing research papers, collaborating openly with the academic world as peers. And many of our researchers are academics or ex-academics themselves, and we work very much hand in hand with academia. This conference is really an exemplification of that. So we're really quite a different organization from what many people think of as a research lab at a company. We don't really work on products, we work on technologies that may feed into products. That's true at Microsoft. You should see a mission statement at the top there. But it's not about product development. We don't work on products specifically. We work on technologies that one day may lead not only to products or features within Microsoft technologies, but also entire new businesses. And Kinect is one of the examples where we've helped such a technology emerge. I'm from the Microsoft Research Connections group, which is a bridging group between the Microsoft researchers that are working on their research papers and their patents and their innovations, and working with academics, with our group in Microsoft Research Connections, where our whole purpose is to bridge those researchers and academia. So our researchers are very busy doing their own research, they have their own academic partnerships. We try and help amplify what the researchers can do and how they engage and partner with academics. We work in a number of different areas. There are 5 main areas, and I'm responsible for one. So I have the natural user interface area here. As you've just been hearing from Cherry, we call the type of technology that Kinect is, it's a enabler of natural user interface technology, an expansion of the current thinking in user interfaces to really bring in multiple modalities simultaneously to work in the speech spectrum, to work in the vision, to look at gestures and integrate that so that you can interact with a computer system in a much more natural way, where you don't have to think about the interaction that you're doing with the computer. You saw in that last scenario with the video showing the shopper at a store trying on clothes. She didn't have to think about she's interacting with a computer. She just tried virtually on her different clothes. It's a natural user interface. So I won't go into a lot of detail about context, but I'm sure you want to hear about the science. But the last piece on context, natural user interface. Kinect is just one example. It is a dominant example for us. It represents perhaps the pinnacle of natural user interface capability. But we think about natural user interface even beyond Kinect as well. So let's stick to Kinect today. Another area that I've been involved with and our group's involved with is in science. And we are co-hosts of this conference. I was particularly co-editor of a book called The Fourth Paradigm, which is a book written a couple of years ago explaining the state of the art in what data-intensive science is all about. we really see, it was observed by a very famous computer scientist called Jim Gray and others, that there was emerging a new paradigm for how science was being done today, the fourth paradigm. The fourth paradigm represents that approach to science which maybe many of you are involved with, where now data is dominant within your science. The amount of data coming from the instruments that modern scientists use is extraordinary. We have gigabytes are easy now. Terabytes are somewhat normal. We're getting into petabytes of data that is now quite challenging to process. And data-intensive science is an important challenge for our scientists today. It's an important challenge also for computer scientists like me to imagine how we can help scientists. There's a lot of words on these slides. I'm not going to go through them today, but you can look at the words after the talk, and I'm happy to answer any questions as well. Just want to give you a taste at first. Here's a famous data-intensive scientist. Hello, Alex. Nice to see you. So let's drill into a little bit more detail about data-intensive science to explain how natural user interface plays a part, how it has a role to play. So this diagram, written by a colleague of mine, it captures a number of our thinking in summing up what the workflow and the process of data-intensive science means today. You can start basically at the top, where acquisition and modeling data is a non-trivial problem. Getting a lot of data of sensors of lots of different kinds. My sensors might be a sensor network in a field or in a forest or in a stream of water. Maybe it's on a satellite. Maybe it's a probe on Mars, the planet. But I'm getting the data and I'm feeding that data in. I have to feed that into an enormous process in itself. I won't go into that today. But collaboration and visualization is an important part of data-intensive science. And you can see there a hint that in visualizing data, especially large amounts of data, we have a non-trivial problem again. And how do I collaborate with these large amounts of data? Sure, I have the physical problem of how do I get data, large amounts of data from one place to another. Using big data centers today, we can put data in the cloud. But how do I collaborate? What communications mechanisms do I use? What's my user interface to that data? What does the collaboration user interface look like? There's analysis and data mining, another non-trivial problem. All of these are non-trivial. I won't go through them all. I hope that as contemporary scientists you're very familiar with these areas. But data is dominant in the center. Perhaps the most obvious opportunity for natural user interface and technologies like Kinect for data-intensive science is in collaboration and visualization, as I hinted just a moment ago. We think that by bringing technologies like Kinect into the picture of data-intensive science, it can help in how scientists communicate and collaborate, how in particular I can visualize data. You may have seen, I'm sure you've seen you've seen the movies that Cherry's just showed of Kinect and how we interact with Kinect in some non-science scenarios today. But I'm sure you've heard of the movie that famously showed the gesture interfaces that have been shown over a number of years. But in some ways it inspired this idea of gesturing to a screen, gesturing to a computer as a novel way to interact with data. What's starting to happen is that with so many people experimenting with Kinect, now it's become so accessible. There are other technologies like Kinect, but Kinect is still the most popular. Scientists and others are also experimenting with what it's like to gesture to an interactive screen and experiment with manipulating large amounts of data. If we've got time, I'll show you a demonstration of our worldwide telescope that has a prototype Kinect interface on it. The worldwide telescope shows astronomical data. The data is come off from many different satellites, the Hubble Space Telescope, all sorts of things. But you can interact with that large amount of data with just a mouse and a keyboard. I could use just a trackball or a conventional user interface. But it transforms the experience when I can gesture to the telescope with my whole body and move around the planets, move around the stars with gestures. I also, because it's a natural user interface, can integrate speech into that interface. So I can speak to the screen, just like again we showed in the fashion video with the lady that was speaking to the system as well as gesturing. We see natural user interfaces, combinations of those modalities. It's not just about gesture. Gesture is just one of the modalities. But gesture, speech, and the other ways coming together is how we see a role for NUI and natural user interface to play in collaboration and visualization for data-intensive science. But I don't think it stops there. I think you can imagine that as you visualize data, eyeballing the data, as in trying to understand and navigate the data, trying to identify features within that data, plotting that data, analysis through the visual medium, if I could gesture to that data, represents an important part of what data-intensive science does, and we think that natural user interface has a role to play. Equally in data mining, trying to extract interesting data and interesting features from large data sets through a natural user interface, I would like to hypothesize with you today, is a good realm of experimentation, and I'd encourage you to explore how technologies like Kinect could be used in that kind of area of data-intensive science. Lastly on this slide, the dissemination and sharing. What if you could hand your data sets in a easy to navigate, easy to explore way with a natural user interface to your colleagues or to the general public? Many data-intensive scientists, many scientists also have an important outreach role. They need and want to explain their data to the general public. Part of the reason for showing you things like the fashion video is not to suggest that this is directly relevant to your science, but think about it, it can also apply to your science, because in the way that we're showing natural user interface is a good way to interact with the general public who are unfamiliar with the system, they don't know how to interact with your system. If you could give a natural user interface that's enabled by Kinect to members of the general public or to government bodies or to people funding grants even, that could help explain your science and explain your data to those folks that are not familiar with the scientific data interfaces that you already have. So I think these three areas really represent prime opportunities, I would like to hypothesize, and we have seen some experimentation already, some of which we've done ourselves, are very important opportunities for natural user interface. I think there are also opportunities even beyond in these other two areas. I won't go into so much detail in probing these. Again, I'm happy to answer any questions you might have. But I do wonder in acquisition and modeling, as you deploy sensors, there may be interesting natural user interface ways to gesture to an interactive environment to deploy sensors in a sensor network. That seems like an interesting scenario to me. And archiving and preserving, we have other thoughts about that, which again I won't go into today, but I'm happy to answer any questions or if you want to get into a dialogue. To sum up, I think that the entire space of data-intensive science represents opportunities for natural user interface. I've not come here today to present you solutions that are off the shelf that you can just use straight away in your science. I don't think the state of the art is there for any company or any platform today in natural user interface. But what we do have, just as Cherry highlighted with the Kinect for Windows technology, it is ready now. It is mature technology which researchers and companies are relying on this technology now to build businesses on. Some of these companies that Cherry showed are startup businesses, and they're starting up their own businesses using Kinect technologies. But there's also big brands like Coca-Cola using this technology, and Nissan was another video that Cherry didn't show, but big companies and small are using this technology. It's proven technology. So this technology is mature enough to use in many different fields. What we would encourage you to today, if you are inspired by some of the things we're saying, is for you to explore what you can do with your data-intensive science applications. I think there are opportunities all over the map here. The scale of data I highlighted earlier. This is a plot, the sources from Southampton University in the UK. There are petabytes of data coming into this field. The amount of data in the field of data-intensive science is just incredible. we are trying to empower through our computer science research, not just at Microsoft Research, but beyond, in the field of computer scientists collaborating with e-scientists. We're trying to help scientists actually be scientists. So today, on the left-hand side, the scientists using conventional technologies are getting overwhelmed with the amount of data. Build is automatic. But tomorrow, and what we think that we are collaborating with scientists like Alex, who joined us a minute ago, the current state of data-intensive science really enables a paradigm shift to bring the ability to address these petabytes of data. I think that NUI has a key role to play in the three areas I highlighted a minute ago, and there are opportunities beyond, as I explained. One of the documents that is in the kit that comes with Kinect for Windows. Kinect for Windows is both the hardware, the sensor itself, which you'll see that from Wave in a few moments. There's also a software development kit as well. But importantly, as we've built up this capability over the past couple of years, we've got extensive documentation now. And this is the front page of the Human Interface Guidelines that were released with the latest version of the software development kit, version 1.8, which was just released, I think in August, right? Was it August? I think it was August. September. The Human Interface Guidelines is 140-odd pages of diagrams and guidelines helping you as a developer to understand how to write the best user interfaces using Kinect technology. There's a large handbook here now how to build natural user interfaces. So you're not alone. You don't just get the sensor device and some APIs in your software development kit and then have to go and write code. You've got extensive documentation built on years, way beyond just the Kinect for Windows project. This includes a lot of the experience in Xbox that have been developing for Kinect longer than anybody. That really helps you build natural user interfaces today. So there's a lot of experience being built up. There's also a large number of samples in the software development kit that can help you get you started as well. So don't be afraid of dipping your toe in the water and trying it. Ray will talk a little bit more about that, or a lot more about that shortly. There's another piece to Kinect. We spent the last 40 minutes or so talking about Kinect as a natural user interface technology. That's what it was designed for. We're originally in a gaming situation, designed to be a new way to interact with games, but we very quickly saw the much broader potential to use in all sorts of applications, in retail, in advertising, and in science, in the areas that I've highlighted. But Kinect also can be used in a rather other interesting way, specifically of interest to scientists. And this is that by taking away things like the what's called the skeletal tracker, the technology that identifies you as a human being with gestures, if you just point the sensor at any object, you still can do some interesting things with it. And in particular, scientists and applied scientists are exploring how Kinect can be used in this way, using a technology that we've released called Kinect Fusion. Kinect Fusion is about surface reconstruction. That's the technical term for what you and I, if you're non-computer scientists, might call real-time 3D scanning. So I can use the Kinect as a sensor to not now just scan people and understand their gestures, but I can scan objects and understand their 3D surface. I can build a 3D model of an object in real time, very quickly. Some of the example scenarios that we've worked with universities to explore include archaeology, to scan archaeological digs and objects, artifacts, criminology, exploring crime scenes very quickly to scan a crime scene or the evidence in a scene, and biology, to monitor things like plant growth. If I can scan a plant that's growing over time and scan it over different intervals, I can build up a growth model for that plant. There are other ways to do these scans. This is not a technology that is novel, if you like, in those scenarios. Each of these scenarios has existing 3D scanners, but those 3D scanners are very different to Kinect. They're very expensive for a start. Those are thousands of dollars in general. They're also extremely slow. They're very precise scanners, but they're very slow. It can take you a day to scan a room in criminology, in a crime scene, to accurately scan a room. And it's great. You get an accurate scan, but it's a day to do this. It takes a long time. Now, the crime scene one is a good one to think about, because if you imagine a crime scene, you've all seen crime scenes on TV if you've not experienced it in real life. Remember, there's a lot of people interacting with that scene, and it's very important where the evidence is in that scene. So it's very important to capture that scene quickly. And as I've just explained, it's going to take me a day to scan it. And I can't have people milling around and moving around in that scene while I'm scanning. I've got to clear out the room. This is not a very good situation. So where Kinect could be useful is not only is it inexpensive, so I can deploy it much more easily and much more quickly. I can give it to people on the scene very quickly, the people in the field. But it's also good for sketching a 3D scene. I think of it as it's an augmentation of a powerful multi-$1,000 high-resolution scanner. What we're giving you is a sketching scanner, a scanner that can just produce a quick and approximate model, which is good as a sketchbook, good as a reference later. So it's a very good augmentation of the existing capabilities of scanning. Some of these applications might just use Kinect alone, but others might use it in this complementary way to existing 3D scanners. And there are a lot more. We ended up talking to about, or exploring about 30 different applications of scanning, but these three were certainly some of the top ones. So I call that 3D sketching, and we're going to give you a demo, I hope, of 3D scanning with Kinect Fusion later, if you have not seen it before. It's pretty fun. So to wrap up and get on with, we'll have a quick break, and then we'll do a technical tutorial on Kinect for Windows. How do you get started? Well, at the top, this is just explaining how if you want to learn more about how we collaborate in Microsoft Research with scientists, there's some starting links there. And again, you can have this deck afterwards. We have a whole community interaction capability where you can go to various places here. I know you can't get Facebook in China, but there are other ways to interact with us. But really my punchline for you is for you to feel empowered to go and explore this yourself. Kinect technology is ready for you to use. It's no longer part of the research lab. The product group is supporting, has developed multiple versions of this. It's at 1.8 now. There is a new type of sensor on its way that's already been announced that will have even more capabilities, even more high performance, and will perhaps expand the scenarios that I've already described. But it's certainly ripe for your exploration to try your ideas in it, and that becomes available in the coming months. So do check out the Kinect for Windows site if you've not done so. Do get one of these sensors. They're very low cost. Try it out, experiment, and see how you can apply it to your science. This is what the website looks like if you've not seen it. So you know when you land at Kinect for Windows you're at the right place. And that is the end of my talk today. Thank you very much. So before we hand off to Wei, I think we should have a quick break. But let's pause for questions. Let's see if there are any questions today. Who's inspired? I'm going to ask you a question. Who's inspired to try this Kinect technology out for your science? Is there anybody in the room that will say they're going to give this a try in their science? Alex, yes. Have you used it for any applications today, Alex? Alex is a famous astronomer. Cosmology? Have you used it on large screens? Okay. How big was your screen? Okay, so that's 6. Right. Do you know any people that have tried connecting a cave environment with large surround screens? Right. Microsoft itself is getting into the large screen displays technologies with the acquisition of the Perceptive Pixel company, which is a large touchscreen display. And I think, remembering Cherry's point that NUI, natural user interface, is very much about multiple modalities. It's not just about gesture. But if you imagine how you could bring in gesture at a distance from a large screen, but also touch to the screen, that combination of modalities is going to be an important direction as we go forward. And you'll start to see these very large touch-to screens become much more common in the not-too-distant future. Did you have another comment? No, I don't think so. Yeah. Right. Thank you, Alex. So one of the examples that I'll get your question in a sec. One of the things that Alex is highlighting at the University of California, Berkeley, you can do these gesture interfaces with historical technology from previous legacy technology, where you need things like a stick or an additional component to the interface. And one of the neat things about Kinect, remember, is that it just works on vision and speech and audio. So the sensor itself can detect what's going on in the room. You don't have to bring an augmentation, you don't have to bring a device to that. You just put your Kinect up in the room. Yes, you do need to do a bit of programming, but the system can understand that there's people in the room. The system can do things like, as Cherry put up earlier on the human interface guidelines, things like engagement with the system in dialogue, determine whether the person is facing the screen or facing the other person in the room. Another important point about Kinect, there's so much to say, but I'll try and shut up in a second. Remember, Kinect is also good not just for single person interaction, one person with the screen, one person with the system, but it's multiple party inherently. It was built that way for games. It was always going to be 2 to 4 players in the game as well as one person. So a neat side effect of using Kinect is you get up to 4-person interactivity capability with Kinect, and that I think is really good to my collaboration point in the science opportunities that I described. Yeah, you had a question, sir. Sorry. Yes. The Cherry can correct me, or Wade can correct me if I'm wrong. In fact, do you want to just answer, because I'll get the number wrong. Is it how many Kinects can we do simultaneously now? So it's simultaneous 2 capability now, yeah. I seem to remember there was an API for 4, but certainly one of the challenges you end up with is not just the physical light interference, so you need to manage that. But it does work. We've seen this done multiple times, but the supported one sounds like a cheat. You will run out of USB bandwidth on a regular PC. So you need to have a dedicated USB host controller for each one of these Kinects, because there's so much data coming off them. That doesn't change with a new version of the sensor. You just get even more data, so you need dedicated USB 3. But it's very possible and people are doing it. It is supported. Yes, another question, sir. What sort of range are you thinking of? Yeah, about a room, a regular living room scale. I don't foresee that myself. I think that still represents a sweet spot of the sorts of interactivity that's designed to support both in a gaming environment, but also for the sorts of interactivity I've been speaking about today, and how you interact with a large data set, for example, in a science scenario. Did you have a particular application in mind? Oh, yes. It's not a driving use case for us, as we say. It's not a particular direction that we're going after. But I hear you. The product team hears you. What they'll do is listen to potential customers like yourself, existing customers like yourself, and if they'll evaluate whether this is a priority to develop it. But at the moment, it's not something that we're hearing is a particularly strong demand. I think the number of people is it's particularly challenging. But Cherry, do you want to comment on any of these directions? But it will be small increases. These are not things that are going to be order of magnitude changes. The technology is not there to do that. With the directions that we're going, you would need a different type of technology to do that. So there's a little bit of a Moore's law thing here, which there's always improvements, but it's not dramatic improvement. Sorry, Cherry, did you? Yeah, there's a bit of a in sensors where we've seen in the computer science field so many different sensors now that you have to choose from, and Kinect just represents a particularly sophisticated sensor integration. But there are many different sorts of sensors to use, and you, as Cherry says, you do have to think about not necessarily just because Kinect's there using it for a particular scenario. There are other sensors that may be used. If I was to try and address the very large number of person problem at a distance, which it sounds like you're doing, I mean, I would be using computer vision, using just regular cameras. I wouldn't necessarily be thinking about using Kinect. Kinect is a convenient technology just to use, but I don't know that Kinect really brings you strong value for that particular scenario. I'm not sure what the depth sensor, for example, might give you in that scenario. You could just use a regular visual camera, maybe multiple visual cameras, and do some clever vision processing. It doesn't need Kinect per se. Yes, Cherry. last questions before we take a break? And we'll hand over to Ray. Okay, well let's just draw it to a close. We'll be open for questions for as long as we're all here until this evening. Let's take a 5-minute break if you need it. Yes? Well, Way's going to get set up, so there'll be a little bit of delay here when we get set up. Thank you for listening so far. Thank you. I hope you enjoyed it.